Okay, question 5H in exercise 17G of the extension textbook has an identity here that we need to prove. So we can start with the left-hand side or the right-hand side. There's a lot more to do on the left-hand side, so I'm tempted to start there and show that it equals the right-hand side. So we can launch straight into it and use our double angle formula here just to expand out this one and this one. Now it's going to get a little bit big and messy, and then we should be able to tidy it right up. So we know that this formula, which you can have your reference sheet out to show you, it says that the tan of one angle plus another angle equals the tan of the first one plus the tan of the second one over 1 minus the tan of the first times the tan of the second. So we need to just go ahead and apply that formula twice here. Now when we get to this one, we'll just change the signs. So we've got the tan of, I'm going to write x on 2 throughout here just so it's a little bit simpler, plus the tan of pi on 4. Now it's a proof, so I'm not going to do anything in my head. I'm going to show my reasoning. I know that the tan of pi on 4 is 1, but I'm not going to sub that into the next line because I want it to be really clear what I've done here. And here I've got 1 minus the tan of x on 2 times the tan of pi on 4. I suppose I don't really need brackets there. You can put them or not, up to you. Makes it a little bit messy, I suppose. Plus, now we need to do this whole section. So we've got the tan of x on 2 minus the tan of pi on 4 all over 1 plus this time the tan of x on 2 times the tan of pi on 4. Okay, now let's just tidy it up one step at a time. All the tan of pi on 4s is just 1. So here I've got the tan of x on 2 plus 1, and on the bottom I've got 1 minus 1 times the tan of x on 2. So it's looking a lot tidier already. Tan of x on 2 minus 1 over 1 plus the tan of x on 2. Now we're trying to get this together to make one expression. So here, if I make common denominators of bracket 1 minus tan x on 2 times 1 plus tan x on 2, multiplying these two denominators together gives me the difference of 2 squares. So on the bottom, I'm just going to have the first thing squared minus the second thing squared. So I can write tan squared x on 2 for the denominator. And for the numerator, just be careful. The denominator of this fraction here has been multiplied by that. So I need to do the same to the top. Now you can see that 1 plus tan of x on 2 is the same as tan of x on 2 plus 1. So I'm really just needing to square this term on the top. But this one over here is a tiny bit different, and it's easy to make a mistake with this one. We've multiplied the denominator of this fraction by 1 minus tan of x on 2, so we need to do the same to the numerator. So that gives us tan x on 2 minus 1, which we did have, multiplied by 1 minus tan of x on 2. Now they look very similar, almost the same, not quite the same. You could square them if you change this sign to a negative, or you could just write them out like that. So there's a bit of variety there. Now, expanding all of this out carefully, we have tan squared x on 2. We need to double the multiplication of these two terms, which is 2 tan x on 2 plus 1. And now over here, we've got tan of x on 2, and we've got another tan of x on 2. So we've got plus 2 tan x on 2, and then minus 1, and we've got minus tan squared x on 2. And the whole thing is over 1 minus tan squared x on 2. Now, you can see here that some of our terms are going to cancel out. Tan squared x on 2 and minus tan squared x on 2. And we've got 1 and minus 1, so they're gone. So tidying up on the top, we've got 2 tan x on 2 plus another 2 tan x on 2. That gives us 4 tan x on 2 over 1 minus tan squared x on 2. Now with this sort of question, every now and then keep an eye on your finish line, what you're expecting this to look like. If we've got the tan of some angle, in fact 2 lots of it, then look at this formula here in red. If we're dealing with our angle being x on 2 plus x on 2 is x. So that means we know that the tan of x is going to equal tan of x on 2 plus tan of x on 2, well that's 2 tan x on 2, minus, and on the bottom, sorry, we'll have 1 minus tan squared x on 2, which is exactly what we've got. So we're close. We're really almost at our finish line. So continuing on over here, if I just take a 2 out of this, I can see that what I've got is 2 times 2 tan x on 2 over 1 minus tan squared x on 2. And this whole formula here is actually just the tan of x. So we're there, and it equals the right-hand side, and we're done.